Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. Our current AI models, especially in deep learning, have a significant black box problem. Their intricate complexity makes it nearly impossible to understand why they make a particular decision. More fundamentally, most of these models operate on correlation, not causation. To overcome these limitations, we introduce Causal AI. This paradigm shift focuses on understanding the underlying mechanisms that drive events. For example, if we know a specific virus causes a disease, we can create a vaccine to target that cause. The goal of Causal AI is to embed this kind of causal reasoning directly into our AI models. Incorporating causal reasoning into AI unlocks a wealth of benefits. First, it leads to improved prediction because the models understand the underlying mechanisms, not just surface-level patterns. This understanding enables effective intervention, allowing us to confidently predict the outcome of a specific action. Causal models are also more robust and stable, generalizing better to new data because they are not reliant on spurious correlations. Causal AI allows for counterfactual reasoning, the ability to ask, what if things had been different, and get a reliable answer. Furthermore, it is a powerful tool for promoting fairness and bias detection by helping us identify the true causal sources of unfair outcomes. Finally, and crucially for this presentation, causal reasoning is the foundation for truly enhanced explainability, a topic we will delve into next. While causal AI focuses on the why behind the data, explainable AI, or XAI, focuses on communicating that why to a human user. As the image shows, the goal is to provide not just an output, but also a clear explanation. This is critically important for several reasons. First, it builds trust and confidence. If we can't understand an AI's reasoning, we'll be hesitant to use it in high-stakes fields like medicine or finance. Second, it improves human-AI collaboration, allowing for better teamwork. XAI also facilitates debugging, making it easier to find and fix flaws. In an increasingly regulated world, XAI is becoming essential for regulatory compliance. And finally, understanding how an AI came to a conclusion can often lead to deeper insights and new discoveries in a given domain. Now we will explore blueprint for building thinking machines with causal and explainable AI. How we can evolve AI from being simply predictive to becoming truly understanding and trustworthy by focusing on cause and effect relationships and clear explanations. The first component of our blueprint is causal discovery. This is the process of automatically learning the cause and effect structure of a system from data. Instead of us having to predefine these relationships, causal discovery algorithms can infer them by analyzing statistical dependencies in the data. The output is often a directed acyclic graph, or DAG, as shown here. This map visualizes which variables are likely causes and which are effects. For example, it might discover that a patient's age directly and indirectly influences their health through their lifestyle. While this process is powerful, it faces challenges like dealing with unobserved variables and requiring certain assumptions about the data. Once we have a plausible causal structure from the discovery phase, the next step is causal inference. This is where we move from knowing that something causes something else to understanding how much it does. The classic method for this is a randomized control trial, or A/B test, as shown. By randomly splitting a group into a control and a treatment group, we can confidently attribute any difference in outcome to the intervention. When a controlled experiment is not feasible, we can use advanced statistical methods on observational data to simulate the conditions of an experiment and estimate the causal effect. This step allows us to quantify the true impact of an intervention, which is essential for making data-driven decisions. The final and most user-facing component of our blueprint is generating explanations. This is where we translate the causal reasoning of the AI into a format that a human can understand and trust. We move beyond simple feature importance to provide explanations that reveal the causal mechanisms. This can take several forms, such as a causal chain explanation that clearly lays out the sequence of events. For a loan application, a simple explanation might be that a low credit score was important, but a causal explanation would state, your loan was denied because your credit score was below 650. Another powerful form is a counterfactual explanation, which answers the what-if question and provides a clear path forward for the user. By integrating these methods, we create AI that is not only smart but also transparent and helpful. The blueprint we've discussed offers a clear path forward for the future of AI. By moving beyond the simple reliance on correlations and embracing causal and explainable principles, we can build AI systems that are more robust, reliable, and trustworthy. We can create AI that doesn't just predict what will happen, but understands why and can explain its reasoning to us. This is the foundation for building the next generation of truly intelligent and helpful machines. I am now happy to take any questions in comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.